So with recursion on Thursday, we saw something that was able to replace a traditional for loop, right? So here I have a function called logs an array, and all it holds is a traditional for loop that goes through an array and prints out each element of the array. Very standard. The problem with this function really is that if I give you an array of just numbers, I absolutely am, and I'm not, and I apologize profusely for that. No, I realized that once I realized my green square wasn't up. Okay, can you guys see my screen now? Yeah, my bad, guys, and thank you for calling me out, whoever that was. Okay, great. Let me just move this. Okay, cool. Yeah, great. So sorry. So on lines 1 through 6, we have a function called logged in array, and all it does is on line 2 we have a for loop that goes through every element in the array, and on line 3 we just print out each element. And this works if I give this function an array of just numbers, right? It will easily go through and print out every single number in the array. But this function will break, or rather, it won't do what we expect it to do if we pass in something like a nested array, right? And so if I look at line 8 there, now I'm passing an array with 2 elements, a 1, and then the second element is an array, and that array has 2 numbers, 2 comma 3. So if I wanted my function to be provisioned so it's able to print out 1, and then 2, and then 3, well, the function as we have it could not work. So the question becomes, how do we do that? Well, here's where the power of recursion really comes into play, because if we think about what recursion does, all recursion is saying is, hey, let's solve one small problem over and over and over again, until we kind of reach our endpoint. And once we do, then we're done and we can move on. Now, if I'm trying to think about the small problem that we're trying to solve here, pretty much it's just, if I give my function an array, can it print out every number in the array? And if that element is not a number, well, I just need to have another iteration of a function that's supposed to take in an array and print out every number in that array, and so on and so forth. And so we begin to see the outline of what our recursive function could potentially look like. So right now, as is, if I feed the input on line 8 into my logged in array function, I get back the following, right? 1, and then the second element, which is just an array with 2 numbers, 2 comma 3. But if I restructure my recursive function out to say, well, I only need to handle 2 conditions. In the first condition, my element is a number, and I can just console log it and proceed as normal. And that basically, if I look at my function now, basically within the body of the for loop, I've now created a if-else branch, right? In the if branch, all I'm checking is to see if the element that I'm looking at is an array. And if it's not an array, I go to my else. And in my else, I'm going to make the assumption that if an element is not an array, that it's a number. And so if it's not an array, then we go to our else clause and we just print out the element. That's what we did before in our previous example, right? Where we assumed everything was not an array and we just print it out. Here, we just do a check, and if it's not a number, then we print it out. So far, so good. The next part of this function then becomes, okay, well, what if something is an array? What do we do with that element? And here's where we actually use recursion to say, well, if something is an array, and I have an array that's filled with potentially numbers and other arrays, well, let me just recursively call myself, because I, as in this logs an array function, I am a function that is provisioned, that is set up to handle taking an array, going through each element, and then making a decision on what to do if something is a number versus what to do if something is an array. And so now I've actually begun setting up basically the backbone of my iterative function. If I run through the input now on line 14 into this function, the first time I call this function, I'm passing in logs an array, and we forgot the brackets there, but hopefully you get the idea. We pass in the array with 2 elements, 1, comma, and then the array. Well, as we go through the first element, which is the number 1, we go through the for loop, we go through element equals array index 0, which is number 1, and we say, is 1 an array? It's not an array, so then we go to our else clause and we console log out 1, okay? Then we move on to the next element in the array, which is the array 2 comma 3, right? And we say, great, is that element an array or not? And on line 5, we check to see if that element is an array, and the answer is yes, it is an array. So then that takes us to line 6 and says, okay, great. Now let's take this array of 2 comma 3 and let's call another instance of logs an array with this array of 2 comma 3. When we do that, then what we're saying is, great, let's now run another iteration or another version of logs in array from the top. Except now array is no longer the array 1, comma 2, comma 3. It's now just the array 2, comma 3. And so then when we feed that array of 2, comma 3 into the logs in array function, the first element that we process at index 0 will be the number 2, so we print that out. The next element that we process will be the number 3, so we print that out. And now we've reached the end of the 2, comma 3 array, and therefore we've reached the end of that logs in array function, right? And by that I mean the second one that we're looking at right now. Okay. Once we're done with that array, we then take that function, now that we've completed it, off our call stack, which we talked about on Thursday, and then I go back to where I left off. Well, where I left off was processing the second element of an array with 2 elements, and so therefore I'm now also finished with this logs in array function as well. And now I've completed my job, and I was able to go through and log out all 3 numbers one by one. Was that clear to folks, or do I need to, or should I go through it again, or maybe slow down on some parts? Yeah. This is a problem that we need recursion for, and so the reason why is because in the example that we've given you, we've shown that there's possibly 2 levels of nesting. But what this function is actually able to handle is, if we go to the next slide really quickly, or actually maybe not yet, but what this problem is able to handle is, what if I have 20 layers of nesting inside that array, right? Like what if it's like an array inside of an array inside of an array inside of an array, etc. Now with this recursive function, we actually don't care how many layers of nesting there is, because each time there's an additional layer of nesting, we'll just recursively call the logs in array function again. And so if I know for a fact that there's only going to be 2 layers of nesting, maybe I could do a more complex if-else statement. But if I don't know how many layers of nesting there will be, then this is probably the best way to solve that problem. Yep. Are there any other questions? Okay, great. So we're just gonna walk through. So this is pretty much all we have for today, actually. Like that was the core concept of just saying, hey, now let's use recursion to solve problems that we can't solve otherwise, and we're just gonna spend the rest of the day doing a few more examples of these types of problems. So here, if I have another example, which is to say that if I have an array of either letters or arrays of letters, and I want to join all of the letters together, how would I do it? Well, if I knew that, for example, if I knew that if I was going to pass in an array in which there was no nesting and everything was just going to be a single letter, well, the way I would join it, assuming I don't use the .join function, I could create a function called concat else that takes in an array. On line 2, I would start with an empty final string. Then I will go through every single element in the array, and for every single element on line 5 there, I just add it to the end of final string. And then finally on line 7, I return final string. And that should create for me a final string in which all the different things have been joined together. Now, the difference here is, of course, if I now on line 13 there, if I now have an input in which the input is going to be an array of either letters or arrays of letters, that's going to change things a little bit, right? So on line 1, we still have our concat else function, we still take in an array. On line 2, we still have our final string, which starts off as an empty string. On line 3, we still have our for loop. But once again, we kind of see our if-else branch occurring between lines 5 through 9. Because here we need to provision our code to handle what happens when the element is just a string versus how we handle it if the array is also an array of strings. So line 5 just checks to see if the element is an array. If it's not, then we jump to the else statement on line 7, which takes us to line 8, and all we do is we add element to the end of final string, like we were doing before. No changes there. But if the element is an array, and here's where it gets tricky. Before, in the last example, all we were doing was console log, so we didn't need to keep track of anything. Here on line 6, notice how what we're doing is we need to call concat else and pass in the new element. So just like in the previous example, we now basically removed one layer of nesting. We're saying, hey, here's this array of just the strings b comma c. I need to get rid of this, and so I would call concat else and feed in the array b comma c. But the difference now is that I actually need to get something out of giving that the array b comma c. I need to get back what I get when I join together the contents of bc, because then I need to take that and add it to the end of final string. Okay, and I'm sorry if that was a bit confusing to describe verbally, but if I look at line 8 there, I'm taking in a single letter and I'm adding it to the end of final string. On line 6, I'm basically taking a bunch of letters, so the contents of that array, of that inner nested array, and then adding that to the final string. So in both scenarios, I need to make sure that I'm adding something to the end of final string. And so that means that when I call concat else and I pass in the element, I need to be prepared to get something back from it and use that thing. So if we walk through our code again for this input, when we initially pass in, we have the array with a and then comma array b comma c, and our final string initially is just blank. As we go through the array, when we reach the first element, we say is a string a an array, and it's not. So we go line 8, and we just add the letter a to the end of final string, and now final string is just the letter a. We then move on into the next element and say, great, is the element the array b comma c? Is that an array? And the answer is yes, it's an array. So then we take that element. So then we take that element and we move on to line 6. And line 6, if I look at the input on the right hand side, bottom right hand corner here, final string is the letter a so far because that's what I added in the previous iteration. And now I'm trying to add in concat else, and I feed in the array b comma c. So what do I get when I feed in the nested array of b comma c? Well, that means I'm calling concat else from scratch, and so that means I'm going to trigger a brand new separate version of final string that starts off as blank, and as I go through every element in the array b comma c, at first it's just a letter b, so that I just add that to the end of final string, and then it's a letter c, so I add that to the end of final string, and then I've reached the end of my array, and we can't forget about line 11, we actually return final string at the end of this function. So effectively, concat else with the array b comma c fed into it returns the string bc, and so we return that to where it was being called, which is a plus or equal and then the string bc. So when we add those together now, that resolves to the string abc, and then we've reached the end of our input because our input only had 2 elements, the a and then the array. And so once we're done with that, we're not done yet. We finally have to go back to return abc out of the concat else function, and so our final input is just going to be abc. Okay, so in principle, it's identical to what we were doing in the previous example. The only kind of tricky or novel thing that we did here is that now we can't just call a function recursively and forget about it. We now actually need to be prepared to receive the inputs, or sorry, to receive the output from that recursive call, and then use that output to do something with it. In this case, appended to the end of the final string variable. Any questions here? Okay, cool. All right then. So we've talked mostly about arrays so far when we talk about nesting, we talk about recursion. But just realize that recursion at the end of the day, it's not a array specific thing, right? It's more of a way of thinking. It's a method of problem solving. And so there's nothing that prevents us from using recursion on things that are not arrays, right? So nested objects is something that's very similar to nested arrays, and it's definitely something that we can solve with recursion, right? Because once again, recursion is just a concept. So if, for example, I have in this case I have an object called SumVals. If I have an object in which all the keys are, by definition, all the keys have to be strings, but all the values are numbers, and I want to add up all the values, well, I could write a SumVals function similar to what I have on lines 3 through 10 there. I have SumVals, it takes in an object, I create an initial sum of 0, I use my for loop to go through every single key in that object. For every single key in the object, on line 6, I get the value, and then on line 7, I add the value to the sum, and then on line 9, finally, we return the sum. Okay, so a very straightforward way for us to go through every single key to get to every single value in the object, and then sum up all those values. Now, if we keep going here, and we say, well, what if we had the problem that we had before, which is that my input could either be a number, or sorry, the value for every single key in the object could either be a number, or it could be another nested object. And so here on line, I guess roughly 14 there, we kind of see the problem of having an object that's actually very complicated and very not infinitely, but very heavily nested, right? So the question now is, how do I add the 1 to the 2 to the 3, right, for the keys A, E, and F? Well, if we draw upon what we had previously with the arrays, right, things actually look remarkably similar. We still have initialize our sum as 0 on line 2 there. We then use a for loop to go through every single key in the object. On line 4, we get the value of every single key in the object. And here, we still have our if-else test, right? We test the type of value. If it's an object, we do one thing. If it's not an object, so we assume if it's not an object, it's a number, well, we just add that value to the sum, right? So that's what we were doing before. But if the value is an object, well, then we recursively call sumVals, and now we take this nested object and we call sumVals with this nested object, i.e. we've now removed one level of nesting. And so we do this over and over again, and as we see on the bottom right hand corner here, when we initially call sumVals, it's this really complicated thing. When we first call it, as we go through the first key, assume now that it's A, we get back the value is just 1, so we add 1 to the sum of 0, and so our sum is 1 after we go through the first key. As we go through the second key, the value for the B key is actually this nested object. And so as we go through our code, on line 5, that returns back true. So on line 6, we say we're trying to get the sum, which is 1, plus or equal the sumVals of us recursively calling sumVals on this inner nested object. So what is the value of this inner nested object? Well, when we call sumVals with this new nested object, we start off with the initial sum value of 0. And then we say, great, let's take a look at the first key and the only key, which is C. Well, what's the value of C? The value of C is another object, right? And so that means we need to call another version of sumVals, except now, as we go through it, we actually need to go through and say, great, now what's the value of that version of that call of sumVals passing in another nested object? Well, that's also going to start off another brand new version of sumVals with a brand new sum of 0. And so then we try to add the value of that object, and that value is another nested object. So then we call sumVals again, and we start off with another sum of 0, and we say, let's go through this nested object now. So now we're at the layer of nesting where it's just an array with 2 keys E and F. As we go through the first value, it's a number 2, so we add it to 0. As we go through the second value, it's 3, so we add it to 2, and we get back 5. And then when we look at line 11 there, we can't forget to return the 5 to whoever called us, right? So now, at the top line, we've determined that the sumVals of this nested object of keys E and F is equal to 5, so we return that back to where it was being called, which was down below, and now we can do 0 plus 5 gives you 5, and we've reached the end of that object because it only had one key value pair. So when we return 5 there to where that was called, it returns us back to the previous line, which was trying to solve for 0 plus or equal to the value, which was 5, so that's 5. And then when we look at that key value pair, there was only one key value pair, the C key value pair. And now that we've done with that key value pair, we now return 5 from there to where that was being called, and that was being called here in our initial sumVals, which was 5. We added to the one that we had from the A key to get 6. And now if I look at this input here, there's only 2 keys. There's A, which is the value of 1, which we've already added, and then there's B, and the value which is 5, which we've just finished calculating. There's no other keys, so now I've reached the end of this object, and I can comfortably return 6 as my final sum. And when I do, I get back 6 as the final output. And so here's an example of a code in which we actually don't care how many layers of object nesting there is. There could be 1,000 more levels, but basically what this function is going to do is every time we see a new layer of nesting, we're going to peel back that layer, take in the nested object, and call SumVals again over and over again. And so our function can effectively handle as many layers of nesting as there possibly be, and we don't have to know how many layers of nesting there is beforehand. Any questions here? Go ahead. Go ahead. So plus equal. Sorry. So let me just do this. Okay. So here, if I do let x equal 6 here, x plus or equal, so say 3. This is the same as saying x is equal to the value of x plus 3. Okay. If I just do x plus 3, this just gives back x plus 3. Oh. So what this takes me to is now x is equal to 9, and in this case, x is still equal to 3. Oh, sorry, x is still equal to 6. And the reason why is because here we're resetting x, and the new value of x is the previous value of x plus 3, right? So 6 plus 3, which gives us 9. Here, all we're saying is, great, x plus 3, but we never changed the value of x here. And so this basically gives us back a 9 that we don't do anything with. We never reset the value of x. So when we get down here, x is still equal to 6. So this equal is very important because this equal sign effectively resets the value of x. Yep. Cool. Any other questions? Cool. If not, that was pretty much it. All we have for today, right? Which is just talking about recursion. Except now, you're kind of almost forced into using recursion because, these are not problems that you can solve with a very heavy for loop, or at least you should not be trying to solve it with very heavy for loops. But as we also saw in the examples, it doesn't mean you don't use for loops. It just means that the for loop is part of your solution as opposed to kind of being the overarching way of solving the problem. So for today's workshop, I'll break us off into groups,